Hello class. In our last session, we have started the topic called bases. We have seen its definition, and after that we have seen what is basic oxide, what is basic hydroxide. Then we also came to know about alkalis, a base which is soluble in water. They are called alkalis. And after that we have came across a statement that all alkalis are bases, but all bases are not alkalis, and we have explained that statement as well. And after that we have seen strong base or strong alkali and weak alkali. Strong alkali and weak alkali. Now, and we came to know that an alkali which can completely dissociate or undergo high concentration of ionization, they are called as strong alkali, and in the example are sodium hydroxide, potassium hydroxide. So when you dissolve in water, they'll undergo a complete ionization to give you positive and negative ion. Same with the potassium hydroxide as well. Whereas a weak alkali is an alkali when you dissolve in aqueous solution, it will only undergo partial dissociation or ionization to produce a low concentration of OH minus ion in the solution. Example, ammonium hydroxide. Example, ammonium hydroxide. So ammonium hydroxide or calcium hydroxide, when you dissolve in water, it will give you a low concentration of OH minus ion. Okay. Next topic that we need to discuss, is acidity. If you remember, in case of acids, we have discussed the term called basicity. Okay. In a similar way, in bases, we have got the term called acidity. The acidity of a base we called. So the definition tells us the number of hydroxyl ion which can be produced per molecule of the base in aqueous solution is called acidity of a base. Okay, that means if you take a base, say for example sodium hydroxide, and when you dissolve in water or aqueous solution, it will produce you one OH minus ion. That means that one OH minus ion will be the acidity of that base. Okay, in a similar way, as we have seen the classification of basicity of an acid, now we'll see the classification of acidity of base. So it can be classified as monoacidic base, diacidic base, and triacidic base as well. In monoacidic base, it is a base that dissociates in molten or fused state or in aqueous solution to produce one OH minus ion. One OH minus ion per molecule of that base. For example, sodium hydroxide, potassium hydroxide, ammonium hydroxide. When you dissolve this base in aqueous solution, it will give you only one OH minus ion, since it has got only one OH group. So they are monoacidic base. Okay, they are called as monoacidic base. In a similar way, for diacidic base, it is a base which in aqueous solution produces 2 OH minus ion per molecule of the substance. Say for example calcium hydroxide, copper hydroxide. These two compounds, when you dissolve in aqueous solution, will give you 2 OH minus ion. So the acidity for this base is 2, and it is also known as diacidic base. Next we have got triacidic base. Similarly, it is a base which dissociates in aqueous solution to produce 3 OH minus ion. Example, ammonium hydroxide or ferric hydroxide. So when you dissolve this in aqueous solution, it will give you 3 OH minus ion. Okay, so this is triacidic base. Okay. So we have classified the acidity of a base into 3 types. Okay. Now next topic we have got how we can prepare base. So we have to see the common methods for the preparation of base. Say for example, the first method is from metals. When metals react with oxygen, it gives bases, that is metallic oxide. So the general equation is metal plus oxygen giving you base. So in place of metal we have got sodium and magnesium. When it combines with oxygen it will form sodium oxide and magnesium oxide, and they are base. The second method is by the action of water on reactive metals like sodium, potassium and calcium. So we can also produce base by the action of water on reactive metals. Say for example sodium, potassium and calcium. So this reaction are also used in the preparation of hydrogen, okay, by the use of water. So active metals, reactive metals, sodium, when reacts with water it will form sodium hydroxide base and hydrogen. This is the general equation. You can follow this general equation to understand these chemical equations. Reactive metal, you can take water, it will give you base or alkali and hydrogen gas. Similarly potassium reacts with water to form potassium hydroxide and hydrogen. Calcium reacts with water to form you calcium hydroxide and hydrogen. So this is the preparation of bases by the action of water on reactive metals. Next, the third preparation we have got by the action of water on soluble metallic oxides. Okay, the general equation is metallic oxide plus water giving you base or alkali. Metallic oxide, sodium hydroxide, sodium oxide, when reacts with water it will form sodium hydroxide. Potassium oxide, when reacts with water it will form potassium hydroxide. In a similar way calcium oxide reacts with water to form your calcium hydroxide. And the next method we have got double decomposition reaction. Okay, fourth method is double decomposition. In this we have got a salt solution and reacting with base, or it can be alkali, it will form you basic hydroxide plus normal salt. Say for example FeCl3, which is a salt, reacts with sodium hydroxide and it forms FeOH3, that is ferric hydroxide plus NaCl. Similarly copper sulfate reacts with sodium hydroxide to form copper hydroxide and sodium sulfate. Ammonium chloride reacts with ammonium hydroxide to give you ammonium hydroxide plus ammonium chloride. And next method we have got by the action of oxygen on metallic sulfides. We can also prepare base by the action of oxygen on metallic oxide. Metallic oxide plus oxygen giving you metallic oxide plus sulfur dioxide. Metallic sulfide is zinc sulfide plus oxygen giving you metallic oxide, that is zinc oxide and sulfur dioxide. Similarly you can take lead sulfide plus oxygen giving you lead oxide plus sulfur dioxide. So these are the methods for the preparation of metallic oxides. Next we'll see we have to see next method is by decomposition of salt. We can also produce base by the decomposition of salt. Metal carbonate on heating can give you basic oxide plus carbon dioxide. So you can take the example of calcium carbonate. On heating it will produce calcium oxide plus carbon dioxide, or copper carbonate can give you copper oxide plus carbon dioxide. So this is by decomposition of salt. Similarly you can have metal nitrate as well. On treatment with it will give you basic oxide, nitrogen dioxide plus oxygen. Calcium nitrate on heating gives you calcium oxide, nitrogen dioxide and oxygen. Similarly you can take zinc carbonate. On heating will give you basic oxide, that is zinc oxide, nitrogen dioxide and oxygen. And the last method is ammonium hydroxide can be prepared by simply dissolving ammonia gas in water. So for the preparation of ammonium hydroxide we need to simply dissolve ammonia gas in water. You'll get ammonium hydroxide, which is a weak alkali. Next we have got the topic called properties of bases or alkali. They have a sharp and bitter taste, and they change the color of indicators. Indicators, last time we came to know, they are the compounds which show different colors in different solution, either in acidic or basic medium. Indicators, litmus, methyl orange, phenolphthalein. Okay, so in this case if you have got blue litmus solution, when you dipped in basic solution it will turn into blue, whereas for acid, blue to red. Methyl orange in basic solution will turn from orange to yellow, and phenolphthalein will change from colorless to pink. Insoluble base does not affect indicators. Okay, And the next properties we have got, they are soapy substance. That means they are slippery to touch. They are slippery to touch. And next, they are strong electrolytes. That means they are good conductor of electricity, and they show a mild corrosive action, slight burn on the skin. Okay, they are not so harmful as acids. Next, we need to discuss about the chemical properties of bases. The first is strong alkalis absorbs carbon dioxide from the air to form carbonates. So if you have got a strong alkali, they can absorb carbon dioxide from the atmosphere to form carbonate and water. Say for example, sodium hydroxide, which is a strong alkali, they can absorb carbon dioxide to form sodium carbonate and water. Similarly with the potassium hydroxide. Potassium hydroxide can absorb carbon dioxide to give you potassium carbonate plus water. The next chemical properties or the chemical reaction of bases is they neutralize acids to form salt and water. This is neutralization reaction, as we know. Base reacts with acid to form salt and water. Example, calcium hydroxide reacting with HCl will give you the salt calcium chloride and water. Similarly, ferrous hydroxide, when reacts with acid HCl, it will give you FeCl2 and water. FeCl2 and water. Next, reaction number 3. If you have got a metallic salt and reacting with the base, it is formed salt and insoluble hydroxide. That means it will form a precipitate, we can say. Say for example, copper sulfate, metallic salt, reacting with ammonium hydroxide, it will form ammonium sulfate and copper hydroxide, which is a pale blue color. Whereas zinc sulfate reacts with sodium hydroxide to form sodium sulfate, and it will form a gelatinous white precipitate of zinc hydroxide. Similarly, if you have got a ferrous sulfate, it reacts with sodium hydroxide to form sodium sulfate plus ferrous hydroxide, which is a dirty green color. Okay. This is the reaction of metallic salt with base to form salt and insoluble hydroxide. Next reaction we have got, when alkalis are warmed with an ammonium salt, ammonia gas is given out. Say for example, if you have got an ammonium salt and you are reacting with alkali, it will give you ammonia gas. Ammonium chloride plus sodium hydroxide, on warming, it will give you salt, that is sodium chloride, water and ammonia, NH3. Similarly, if you take calcium hydroxide, it will give you calcium chloride, water and ammonia. And if you take potassium hydroxide, it will form potassium sulfate, water and ammonia. So these are the chemical reactions of bases. So today we discuss about, if I have to summarize, today we discuss about, the first thing that we discussed about was what is acidity of a base. Then we have seen its classification, how we can classify it on the basis of number of OH produced in aqueous solution. And after that we have seen the preparation of bases by different methods. And then we came to learn about the physical properties of bases or alkalis, and there we also came to know about the indicators color change in basic medium. And after that we have seen the chemical reactions. That means the different chemical reactions of bases, with the different compounds. And over here the equations are very, very important. You need to practice the equations.